Okay, this is an example of a vectors question where you split a line in a given ratio. I do one with numbers, and then I do one where the vectors are represented with letters, which is potentially the sort of question you'll get, I think, if you get one of these. So, e.g., we can find the coordinates of P which is 1/5 of the way along AB, where A is at -2.8 and B is at 13.3. So I can sketch this one. In a sense, you don't need to, but I think it'd be good for you to visualise what's going on. So we have A at -2.8 and B at 13.3. So over here somewhere. Sorry about the dishwasher in the background. And P is 1/5 of the way along AB. So there's AB. So P is here somewhere. You could do this with coordinate geometry, but I want you to think about working with vectors. So I know I've said this before, but when you're working with vectors, you need to be thinking about travelling along vectors. So if I can find the position vector of P, I can turn that into coordinates, and the position vector of P is going to be the position vector of A plus 1/5 of the way along AB. So end of last lesson we looked at this. AB as a vector is equal to the position vector of B minus the position vector of A. You can work in column vectors if you want to. Position vector of B is 13.3 minus position vector of A, which is -2.8. 13 minus -2 is 15. 3 minus 8 minus 5. So to find the position vector of P, we go from the origin to A plus 1/5 of the way along AB. So we're travelling along vectors and treating this as a vectors question. So that's -2.8 plus 1/5 of 15 is 3, 1/5 of -5 minus 1. That gives you 1/7. And so P as coordinates is at 1.7. So you can go from position vector straight into coordinates. So travelling along vectors. So if I do one that's sort of a little bit more letters based, so we're going to have an origin, position A, position B, position C, and then we've got position vector of B, position vector of C. So position vector of A you can call a lowercase a, position vector of B is lowercase b, and position vector of C is lowercase c. So that's another notation for position vectors. That's the same thing as O, A. And then I'm going to take 2 points, one is P, one's Q, and P and Q are midpoints. I'm going to have to get some thinner pens, I think. This is just about okay. So halfway along AB we've got P, halfway along BC we've got Q. So to find the position vector of Q, so position vector of Q, I can go from the origin to C plus half of the way along CB. So origin to C plus a half, and then CB is position vector of B minus position vector of C. C minus a half C is a half C, so we end up with a half B plus a half C. You could go OB plus a half BC, similar way. You might want to try this at home, and you will get exactly the same thing, but we're just coming round this way instead of this way. Similarly, you can find the position vector of P. I'll let you do that one, I think. I'm a bit worried about the storage of my phone running out. So position vector P comes out as a half A plus a half B. And then if you want the vector that takes you from P to Q, so we're actually finding this vector here. It's a little bit less intuitive. Then you can do position vector of Q, so it's the second one, minus position vector of P, which is the first one. And then we can literally work with this. So it's a half B plus a half C minus, try and remember to underline your vectors, minus position vector of B, which is a half A plus a half B. Which takes us to there. And then tidying that up a little bit, the half B's are going to cancel out, and you get a half C minus a half A. So that is how to divide a line in a given ratio. And just think about working with position vectors where you don't have coordinates with numbers, but we really think about travelling along these vectors.